Hello, thank you for joining me today. This is the core of the factoring polynomials process. This is factoring trinomials in the form where we have x squared, that is a variable squared, plus something times that same variable, plus something else. Okay, now these are considered the easy problems, and I think you'll agree they're pretty easy. I'm going to show you the process that works on all polynomials in this form, and you know that you are right when you're finished. Like, you know you're right, and you know if they can be factored when you're finished. Like, there's no question. A lot of people talk about guessing and checking. There's a lot of guessing and checking that goes along with these. Also, I'm going to go ahead and show you what to do if if the sign here is positive or negative, and if the sign here is positive or negative. And we'll see that there's slight differences in where those come from and what the answers look like. But the process that I'm going to go through is going to be the same, so that I'm not going to care what the signs are. I'm going to go through the same process, and I'm going to get the final answer. So I don't want to. I'll point out the differences, but I don't want you to get too hung up on those, because what's really important is learning this one process that works in all cases, as long as there is no number in front of our x squared here. That's the big deal. So let's get started. Well, let's think about this first. Let's think about kind of what we're trying to get. We're trying to get a pair of binomial factors, x plus, let's say, m times x plus n. Okay, now don't get freaked out about using all these n's and m's and everything. But remember that when you're multiplying two binomials together, you do the first terms. X times x is x squared, plus x times n is nx, and x times m is mx, and then plus m times n. And the big deal is that these two middle terms add together, so you end up with n plus m times x plus mn, and then, oops, I forgot the x squared here. I forgot to write the squared sign. Okay, now the idea is that you end up with a trinomial. But where did that trinomial come from? Well, x times x is x squared. That was easy. But the other parts, the two other parts, well, the c part, the number at the end, came from the factors of c are the numbers that go in my binomials, right? X plus something and x plus something else. Those two somethings are multiplied together to get c. So c equals m times n. And then b, the middle term, it came from adding those two numbers together. Each of those numbers got multiplied by x and mx, and then you added those together. So b equals m plus n. In other words, we can really narrow down what our choices are for m and n, for the numbers that go in our binomials there, if we look at our last term and we just say, well, what times what equals that number? There's got to be two numbers multiplied together to get that number. And then further, we can further narrow it down to say, well, if you add the two numbers together, you need to get that middle term. You need to get that middle number. And that's what we're going to do. Okay, so we'll start out with the easy one, x squared plus 3x plus 2. Here's the steps. You go to your last number, which is, in this, the constant term, plus 2. It's positive 2. And I'm going to write that down, positive 2. And it's important to include the positive because sometimes it's negative. Positive 2 is, and now I'm going to just write down all the factor pairs I can think of. Okay, so it's 1 times 2 is 2. And that's it. 1 times 2 is 2. Oh, wait a second. We could say negative 1 times negative 2 is also 2. Okay, so that's all the factor pairs I can think of. Order doesn't matter, so I don't write 2 times 1. And then I say, well, which of those factor pairs adds up adds up, so I bring in here and I change that times sign to a plus sign, adds up to the first term. Well, 1 plus 2 is 3. Negative 1 plus negative 2 is negative 3. And in fact, it's the first pair that add up to the middle number. The first pair of factors of 1 times 2, that add up to 3. And so now I can fill in my binomials. Remember, my binomials are x plus something and x plus something else, and the two somethings are 1 and 2. And there it is. And I almost don't even need to check this because it's so obviously true. X times x squared, x times 2 is 2x, plus 1 times x is 1x, 1x plus 2x is 3x, and then 1 times 2 is 2. So I don't even, like I can mentally check this. I don't even think I need to write it down, although you might want to if you're still not really comfortable with multiplying binomials together, doing the FOIL method. It's a whole other recording, so if you're still a little bit sketchy on that, you probably want to check your work on these. Okay, let's do that process again. We're going to do it a bunch of times. First step, take the last number, the constant, we call that the constant term. In this case it's positive 6. And we write down all the factor pairs, and this is how I do it. I don't just randomly think about things that multiply together to give me 6. I start with 1. 1 times 6. And then I go 2. 2 times 3. And then I go to the next number, 3. Well, wait a second, we already used 3. 3 times 2, we don't have to write 2 times 3. So we're done. Those are the only factor pairs. Well, wait a second, those are the only positive factor pairs. Let's do negative 1 times negative 6. I don't have to think about that. I just have to recognize that two positive numbers multiplied together give me positive 6, and two negative numbers multiplied together give me positive 6. So those are all the choices. Now we come back and we turn all the plus signs, or the times signs into plus signs, and we just say, okay, which of those gives me negative 5? And 1 plus 6 is 7. 2 plus 3 is 5. There's a hint. Negative 1 plus negative 6 is negative 7. Negative 2 plus negative 3 is negative 5. Bingo, that's the pair. And so there's the ones I'm going to put into my factors. X minus 2, x minus 3. Now, notice, and this is something that's very, very common, notice that the factor pair that worked was the last one. It's the last one that I did. If I was guessing and checking, I think these would be the last ones I thought of also. So guessing and checking, it's really easy to get discouraged when you're just guessing and checking. You're like, I can't think of anything. I've tried 3 different things and nothing works. The fourth one is the one that worked. So guessing and checking is really, sometimes you can hit upon it really fast, especially if it's easy. But being methodical and starting with 1 factors, the factor pairs starting with 1 and then 2 and then 3 and so on, until you either find your answer or you find that there's none left that work, is a really important. It's important to be more methodical on these than to just kind of be freewheeling. Okay, let's do it again. This time I have the coefficient, the constant term is negative 3. So I'm going to write negative 3. And now the factors of negative 3, now this time I'm going to start with 1. 1 times what? Well, negative 3. And then I'll do 2, and 2 doesn't work. 2 doesn't go into 3, so then I'll do 3 times what? Well, negative 1. Notice that one factor is positive, one factor is negative because my result is negative 3. And that's it. That's all we've got. So now, so we don't have to write a second pair of all the negative versions because I've got that already. 1 times negative 3, 3 times negative 1. I'm going to add them together. 1 plus negative 3 is negative 2. 3 plus negative 1 is positive 2. And I was looking for a positive 2 because my middle number is plus 2x. So I found it. X plus 3, x plus -1, or x minus 1. And there we have it. Now, notice this is each of these problems that we've done so far have something different about them. Let's see if I can get them all on the screen here. In the first one, the sign was positive. Both signs were positive. And the factors were positive, and we have x plus 1 and x plus 2. The second one, the last sign was positive, positive 6, but that came from multiplying two negative numbers together, which is why we have a negative number first. So we have x minus 2 and x minus 3, because two negatives multiplied give me a positive, but two negatives added give me a negative. In the third one, the last number is negative, which means that my two factors are one's positive, one's negative. When you add a positive number and a negative number, sometimes you get a positive answer, sometimes you get a negative answer. So those are kind of some small patterns that you can kind of be aware of. But notice I didn't need to be aware of them as long as I was working out the process carefully. So let's do a few more problems. The constant term is -3 again, -3. Oh, and this is just, we're just going to compare this one to the last one. So -3 was 1 times -3, and 3 times -1. We add 1 plus -3, we get -2. 3 plus -1, we get +2. And we're now looking for -2. So the only difference between these two was it's x plus 1 and x minus 3. The signs are reversed. Notice that the factors, the two binomial factors, the order doesn't matter. So if I said x minus 3 times x plus 1, it's the same thing. So you're checking your answers in the back of the book. Don't be worried about the order of the binomials. All right, now we'll do a couple more just to kind of slam these out and see the process. We'll see if we can do these a little faster. We'll see if we can come up with some shortcuts. So positive 24. Well, that's 1 times 24. 1 plus 24 is 25. 2 times 12. Well, 2 plus 12 is 14. And then let's see, 3. Does 3 go into 24? I know the answer is yes, because 2 plus 4 is 6. Remember, if you have a number and the digits and the number add up to 3, 6, or 9, then you can divide by 3. So this is 8, and of course 3 plus 8 is 11. Okay, and then let's do 4. 4 times what equals 24? Well, 2 times 12 is 24, so if I take 12 and cut it in half again, I get 6, because that's like dividing by 2 and then dividing by 2 again. So 24 is 4 times 6, and 4 plus 6 is 10. Well, wait a second, 10 is what I was looking for here. So I don't need to finish this off. And notice that I could keep going. Now, the next number that's going to work is 6, so I don't need it anymore, but I could write the negative versions, but I don't need to because I found the one that works here. So x plus 4, x plus 6, and that's all she wrote. Let's go to the next one. -27 is the constant. I like to, just because I like to be careful with my negative signs and not get them mixed up, I like to put the negative sign first. So -1 times 27. If I add that together, I'll get 26. -2. Well, wait, 2 does not go into 27, so I'll skip 2 and I'll go to 3. -3 times, let's see, 9, right? 3 times 9 is 27. If I add -3 plus 9, I get 6. Oh, wait, that's what I was looking for. So I can stop. I could have kept going. I could have done negative 9 times 3 and negative 27 times 1. But I don't need to because I already found the answer, so I don't need to keep on going. X minus 3, x plus 9. Let me say a quick word about that. Why can I stop? Well, I found the answer, and the only time that there's going to be more than one answer is if there's a common factor in here somewhere that I didn't notice. So that and that wouldn't even show up on these ones, so it's not even a worry. So there's only going to be one answer to all of these. There's only one pair of factors that multiply to get the end number and add to get the middle number. So this is kind of nice. There's only one way to do it. Okay, let's do the last one. The constant term is 14, positive 14. So 1 times 14. Oh, can we do a shortcut here? Well, there's two things I could do. First of all, I know that the middle term, the one I'm looking for, is negative 9, so I know my two factors are going to either both be positive or both negative, and so they have to be both negative, so I end up with a negative number. So I could go to all the trouble of writing negative 1 times negative 14. Adding those up, I get negative 15. Or I could just dispense with the negatives and just do positive numbers. 2 times 7, 2 plus 7 is 9. And then recognize that, okay, so negative 2 times negative 7 is positive 14, and adds together to be negative 9. So I can whatever I'm most comfortable with in doing the math. And there we have it. We found our final answer, and that is how you factor trinomials in the form where the first term is a variable squared, x squared or something else, but no the coefficient is 1. No coefficient other than 1. There's no number in front. I hope to see you in the next recording where we'll talk about those tricky problems with a coefficient other than 1. Thanks for watching.